Hey there, we're going to make a perpendicular bisector. So what do we mean by that? Well, first step is we're going to make some kind of line. So I would come down. Some people put it right up against the words. I don't. Let's come down here and leave yourself some space. So make a line kind of more in the middle where there's some room. There's some room above and below. So don't crowd it up to things. So this line here, let's call this line AB. And you can call it whatever you like, but AB is easy. So we have line AB, and what we would, sorry, I got some marks on my paper. I'm not sure how that happened. What we'd like to do is we'd like to, perpendicular means we'd like a line that crosses it at a 90-degree angle, and then bisector means that that perpendicular line should cross it exactly in the center between A and B. Should cross precisely halfway between A and B. So that means that we need to do some work here. So we can't just guess. Here's what I think we should do. Let's take our compass and let's start at A and let's open it up to more than halfway, something that you know is more than halfway. Make a nice big arc around A and then come from B and do the exact same arc. So you're coming from A, you're doing this arc here, and then you're coming from B and you do the exact same arc. Now, we then notice that this point here, let's call this C, I think C is equally distant from A. If we kind of draw a little faint line here, it's the same distance from A as it is from B. Why do I think so? I think so because we can measure it. See, A to C, and it's also the same as B to C. So because it's equally distant from A and B, it must be sitting over the center line. And the same is true of this guy down here, D. So that means that the center between A and B must fall between these guys, must fall right here. And that guy here we'll call M for midpoint. So I think that we have created M, which is the midpoint, and it's also a right angle. Why is that? Well, I don't know how we can sketch this in, but we know that AD is the same as BD, right? And AC and BC are the same. So really this is a rhombus that we're kind of creating here. And in this rhombus, if you connect the vertices together like that, I don't want to get it too fancy, but I'm pretty convinced, at least for the moment, that that's in the center. All right, and so I'm now going to, let's just go ahead and write down what we just did here. We have line AB is, sorry, let's write this better. I got distracted at a phone call come in. AB is perpendicular to, so it's kind of an upside down capital T. AB is perpendicular to line DC or CD, same thing. So AB is perpendicular to CD. Also, line segment AM is congruent to line segment MB. So what are we saying? We're saying here that this is perpendicular. That's what we're saying with that. And here we're saying that M is the midpoint. Because we're saying AM is the same as MB, so M must be in the middle. So now we have a perpendicular, check, bisector, check. That's it.